And then part 3 says, using the value found in A, find the value P for which these equations are consistent. So when we find that we have a determinant of 0, what that means is that the solutions aren't unique, but that leaves us with two options. The equations will either be inconsistent or consistent, and if they're consistent, there's a set of infinite solutions. If it's inconsistent, then there's obviously no solutions. So they want it to be consistent here, and they want to know what value of P makes the equations consistent. So we're going to use the 2 from before, and we know we can't use the matrix because the determinant's not 0. Sorry, the determinant is 0. So we're going to just use the equations. And I'm going to use the reducing the rows technique that you might have been taught in chapter 1 of the FP1 course. So I'm going to get rid of the x's in the second and third row. I'm going to get rid of the y in the third row, and that will help us find this value of P that we're looking for. So first thing I'm going to do is I'm going to take away multiples of row 1 and row 2 from each other to eliminate this 3x. So I'm going to want to change or get a new second row and I'm going to take 2 lots of R2 and I'm going to take away 3 lots of R1. And for the third row, the new third row, I'm going to have 2 lots of row 3 and I'm going to take away 5 lots of row 1. Because then I'm going to be doing 6 take away 6 and I'm going to be doing 10 take away 10. Nothing happens to the top row. So, as we said, 2 lots of this take away 3 lots of this is going to be 0. 2 lots of this, so that's 4y, take away 3 lots of this is going to just be y. 2 lots of z, so 2z, take away 3z is going to be minus z. So 2 lots of this, 2p, take 2, take away 3p's is going to be minus p, take 2. So the third row, again the x's are going to disappear. 10x take 10x is what we wanted to happen. So then 2 lots of this is 6y, take 5y's is just y. 4z take 5z is going to be minus z. And then again 2 lots of this is going to be 2p take 4, take away 5 lots of this is going to be minus 3p take 4. So if we now eliminate the y from this just by doing the original row 3, take away the row 2, top 2 rows are now going to just stay the same. Bottom row though, the y's are going to go, the z's are going to go as well. So we're going to end up with 0 equals. So minus 3p take 4, take away this is going to become minus 2p, minus 4 minus minus 2 is minus 2. So we need this to be true. So it will be consistent. The equations will be consistent if minus 2p take 2 is equal to 0. So that's going to be when 2p is equal to negative 2. So in other words, when p is equal to negative 1. That's the value of p that we're looking for.